So we just finished reducing fractions to lowest terms. And along in that with that same idea, we can multiply and divide fractions together. If I want to multiply the fraction 6 over 25 times 35 over 9. When we're multiplying fractions together, remember that all we have to do is multiply the top times the top and the bottom times the bottom. So I'm just making things up, which means big numbers that I wasn't planning. I believe that's 210 over 25 times 9, 225. And then what would I have to do with that fraction? I have to reduce it to lowest terms. Right, so while mathematically this is correct, and if I plugged away at this and took out a 5 and then maybe something else and then maybe something else, then I could get that put in lowest terms. Now instead of doing that, because I know that multiplying fractions means tops times tops and bottoms times bottoms, okay, instead of putting the 6 and 35 together, putting the 25 and 9 together, okay, and then trying to figure out how to reduce it, I can reduce first, like I did up above. Okay, I can look at the 6 and say if there's anything in common, any common factor between 6 and 25 or 6 and 9, I can reduce and get it gone right now. So 6 and 9 both have a factor of 3. So if I divide out of 3, out of both numbers, I'm left with 2 on top and 3 on the bottom. 25 and 35 both have a factor of 5 involved. Okay, so I can divide out of 5 out of the 35 and the 25. Once I've broken things down, 2 and 7 on top have no more common factors with the 5 and the 3 on the bottom. Then I can put the tops back together, and I can put the bottoms back together. And I can double check and make sure I'm in lowest terms. And what 14 over 15 is. I can't reduce that any farther. Just a second to scroll around. If I took a 5 and a 3 out of both the top and the bottom on the 210 and the 225, I would also get 14 over 15. If instead of multiplying fractions, if I was asked to divide, I was asked to take 6/25 and divide it by 9 over 35. Remember that division is just a multiplication problem. Okay, all subtraction can be thought of as addition, all division can be thought of as multiplying. When we're dividing two fractions, the first one stays the same. And instead of dividing by 9/35, I can multiply by 35/9. I flip the second fraction over. When I do that, I don't forget to change my division sign into multiplying. Okay, if you leave them both as divided by, it's not a correct statement. Now this is just the same problem that we had up above. 6 and 9 have a 3 in common. 35 and 25 have a 5 in common. I put the pieces back together, and I have 14 over 15. While it's perfectly acceptable in the problem up above to start with the 210 over 225 and then reduce, okay, we are not going to want to do that when we're multiplying and dividing things that look like this. When we're multiplying and dividing, and this is a good practice with numerical fractions as well, but it's nice to reduce in the first step and then go back and put your pieces together if you have pieces in more than one place. Alright, so let's say we have x squared plus 3x plus 2 over x squared plus 4x plus 4. And I'm asked to multiply that by x squared plus 5x plus 6 over x squared minus 9. Again, what I am not going to do No matter what, absolutely not. I am not going to take x squared plus 3x plus 2 and multiply it by x squared plus 5x plus 6 to get x to the fourth plus some really big mess behind it, and then do the same thing to the bottom. Okay, if I do that, I'm going to have, I mean, it would be correct algebraically, but to get it in lowest terms would be next to impossible, because it would not look like the things we've been factoring to break down. So our next step is to factor. I need to factor the top, I need to factor the bottom, I need to factor this top, I need to factor that bottom. Okay, and once I have all four pieces factored, then I can start reducing. Any factor that's the same on either top with either bottom. Okay, go ahead and pause the video and factor everything at your desk or your table or your bedroom, wherever you are. Okay, factor everything and then reduce. Then turn on the video and see if you're in the right place. Two numbers that multiply to be 2 and add to be 3 are 2 and 1. That multiply to be 4 and add to be 4 are 2 and 2. That multiply to be 6 and add to be 5 are 3 and 2. And difference of squares to multiply to be negative 9 and add to be 0, if you want to say that. Okay, positive 3 and negative 3. As we start looking, we're looking for anything that's the same on either piece on the top with either piece on the bottom. So for example, the x plus 2's go right away. Okay, but also this x plus 2 can go with one on the top and one on the bottom. X plus 3's are also gone. And I don't see anything else left to mark out. So I have x plus 1 left on the top and x minus 3 left on the bottom. Okay, factor and cancel. Factor and cancel. If we have a divided by sign here instead, maybe I have x squared minus 2x minus 8 divided by x squared minus 5x plus 4. I want to take that times x squared plus x minus 2. I like that. Over my brain just went dead. X plus 3 because my brain's dead. It's been a long day already for me. Now, first thing, well, there's two first steps. You can do them in either order, and many of you can do them all and absorb them all in one step. Okay? All four of these polynomials need factored if possible. Of course, x plus 3, nothing to break down there, so I'm done with that. Three things need factored. Also, because this says divided by instead of times, okay, the second fraction gets flipped upside down. Some of you can do that all in one step. Some of you need to do it in two steps, whatever you need to do. Okay. So we need to factor top left, bottom left, okay, and the top right needs factored, but it'll end up on the bottom under the x plus 3 when we're done. Okay, so pause, factor, turn it back on when you're ready. Now, it doesn't matter, again, I will say it doesn't matter whether you factor and then flip, whether you flip and then factor, whether you do them all in one step. However, both things need to be done before you start canceling out. Okay, some of you will start canceling too soon, and you're going to cancel the wrong things. Once I have both factored and flipped, I notice the x minus 4 here goes away, x minus 4 and x minus 4. X plus 2, I have one on the top and one on the bottom now. Those also go away. Now notice there's two x minus 1s there, but where are they both? They're both on the bottom, which means they don't go away. They don't cancel out. They both are stuck right where they are. When I go to write down everything that's left, I still have x plus 3 on top, but it looks like that's all. It's all by itself. On the bottom, I have 2x minus 1s. You can write them side by side like I did. If you don't like that and want to write x minus 1 in parentheses, that quantity squared, you may write it that way. Okay, but they are there, and both of them are there. Okay, please don't FOIL that out and call it x squared minus 2x plus 1. There's not a reason to do that. I think your author, some authors do if you're looking in the back of the book, but I can't tell you that there's a good reason ever to put those back together. Just leave them in factored form and circle this guy for your answer. When you are multiplying fractions or dividing fractions, and it took me 11 minutes to do 2 problems because I said a whole lot. But whether we're doing multiplication or division, or whether we're reducing to lowest terms, it comes down to 2 steps. You factor and you cancel. You factor everything and you cancel. Whether that's just 2 terms, top and bottom, or expressions, or whether there's 4 of them all together. Okay. With division, there is a 3rd step. It's factor, flip, and cancel. Okay. Reducing and multiplying, factor everything and cancel. Division is factor, flip, and cancel. Okay. The things that you will have to factor, when I'm just making them up off the top of my head, they all have 1s in front of the x squared. Okay. But you might have something as simple as a greatest common factor that comes out, like you did here when we were reducing. Okay. Maybe it's a difference of squares, like you had to do here. There are some problems in the book that have a sum or difference of cubes. Maybe I have a 2, in front of the x squared, and so I have to set up a grouping problem. Anything we factored up to now is fair game, and you will potentially see it in 1 or more problems in your textbook. So if you're not good at factoring yet, please get that under control before you tackle this, because you need to be able to factor, have to factor well to be able to tackle this material.